Dear students, welcome to my YouTube channel PCM Academy. We are in a lecture series of Vector Algebra, and the course is basically designed for class 11 students and NEET and JEE Main Advanced also. So this is details course structure actually. It is not something like crash courses or one shot video. So this is a details course structure that is contained whole syllabus, detailed concept, solved examples, and a lot of practice problems also. And the problems are so designed that you can crack the exams something like NEET, JEE Main and JEE Advanced also. We'll discuss different kinds of problems for advanced also. Okay, so I will tell you later, and step by step you will see what we are going to discuss here. So stay tuned with us and please subscribe my channel if you are new in this channel. Okay, and in the last class I have discussed something about basic definition of vectors and scalars also. So we have discussed a lot of things in the last class, and if you are new in this channel or in this course, then please see the lecture 1 first. Okay, today basically we will discuss some important types of vectors and the basic notation and geometrical representation of vectors. So first let me tell you about the vector notation. So how you can denote a vector. A vector is denoted something like by using the capital letter, something like A, B or C with an arrow. Okay, so a vector quantity can be written like this. Something like if you have a vector like force, force is a vector quantity, and we denote force by the capital letter F. Now if you want to denote this force as a vector quantity, then we will use F with this arrow sign. Okay, so this is the notation that we use for a vector quantity. But sometimes students have some misconception about this arrowhead. Some students think that this is for direction, but no, this is not for direction. This is just for a notation. This just denote a vector quantity. Okay, and I have told earlier in the last class that there is also another quantity called tensor quantity, and vector is a tensor of rank 1. So to denote the tensor of rank 1, we use this arrow sign. But if the rank is 2, then we use something like, we will study later on something like moment of inertia. This is I, and this is a tensor quantity, so we will denote it like in this way. So this is this two directional arrow, and this is the one directional arrow. You can see this two directional arrow is used for tensor of rank 2, and this one directional arrow is used to tensor of rank 1. So this is not something like this is not denote some direction, or it not represent some direction. It is just a notation. Okay, so if a vector is pointing towards this direction, we will use this, and if a vector is pointing along this direction, then also we will use this. So this arrowhead is not showing direction, any direction. Okay, so please keep in mind, if you want to denote a vector quantity, then we can use the capital letter with an arrowhead. This is one kind of vector notation, you can say. But another kinds you can use something like small letters also. So A, B, C with an arrowhead, there is no problem. But sometimes we use a notation that is not with an arrow but with a bold letter. Okay, something like this. If you write by using the bold letter, so these are also vector. But we will not use this in pen paper because this is difficult to write. But in printed copy, sometimes in various kinds of books, many authors use these notations also. So you should remember this. So you should know actually, because if you don't know about this, you will face some difficulty when you read some advanced book. Okay, so you need to know about the different kind of notations of vectors. Okay, sometimes vectors are denoted something like this. If A, this is a vector, and underline notation, this kinds of things. Okay, so some books or some authors use this notation also, but this is the more popular notation. Okay, that is a capital letter with an arrow. Okay, so this is all about vector notation. Now let me tell you about what is the geometrical representation of vector. Okay, so whenever we want to talk about a vector, a geometry will involve. I have told in the first class also, when we talked about the vector, various kinds of definitions of vector. So that in that class I have told you that why geometry is needed. So in vector algebra, we have to use the directions also. In scalar algebra, what we have done, we have just add some numbers or some variables, something like x, y, z. But here in vector algebra, with the numerical value, we have to concentrate on directions also. So the direction is defined by using geometry. Okay, so you need to understand about the geometrical representation of vector. So let me take you and tell you some examples. Okay, so how you can represent a vector quantity by geometry. So let me first tell you one example first. Okay, suppose you know displacement is a vector quantity. Okay, you might have studied in your earlier classes that displacement is vector quantity. So let me write some displacement. Suppose 10-meter displacement, 10-meter displacement along east. So how can you represent this? Okay, so we have to use the direction east, west, north, south. So this is east direction, you know, this is west direction, this is north, and this is south. So whenever you talk about 10-meter displacement, so we have to go 10 meter along this, and we will use arrows. So if this is 10 meter, just 10 meter, so you can use that 10-meter displacement with this straight line. So with this line, something like this. Okay, so this is a vector. This is saying that the 10-meter displacement along east direction. Okay, so similarly, if you write that suppose 5-meter displacement along north, suppose 5-meter displacement along north, suppose along north. Okay, so how you can represent? So this is the north direction, so we can use this. Okay, so this is 5 meter and this is 10 meter. So obviously it should be greater than this 5 meter. Okay, so this straight line, you can see the line that we have drawn here is actually denote the magnitude, that is 10 meter, and this arrow sign here is actually the direction. Similarly, here you can say the length of this line should be 5 meter, and the arrowhead is denoting that it is pointing towards north direction. Similarly, here also it is pointing towards east direction. So basically, to represent a vector in a plane, in a geometrical plane, what we have to do, we have to just draw a line along that direction, and by using arrowhead along this direction. So simply, if you want to represent a vector in general, otherwise displacement, there are many other vectors. So if you want to denote a vector quantity, we have to choose a geometrical plane, and instead of east, west, north, south, we will use x, y coordinate. Okay, so we can use this as suppose as y-axis and this as x-axis. Okay, suppose this is your x-axis and this is your y-axis. Now if you want to denote a vector a, suppose a, which is making an angle theta with the x-axis, suppose making an angle theta with the x-axis, so how can we represent? So we have to draw a line. The magnitude of the line, or the length of the line, is equal to the magnitude of, and we will use for magnitude, that is mod a, and that is just simply a. So this is denote the magnitude of it. This is actually the magnitude of it. Magnitude of a vector. Okay, and the length of the line should be equal to this, or you can say proportional to this. So suppose this is a vector a, something like this, a vector, and this is making an angle theta with the x-axis. So we can, so this is how we can represent a vector in general in a xy plane, that is in a geometrical plane. Okay, so here we use a straight line with an arrowhead, and the length of the straight line is actually the proportional to the magnitude of this vector. Okay, so if the vector is more, the magnitude of the vector is more than the length of the line is more. So if this is suppose this is a vector, but if you want to draw the 2a vector, this is a vector, and the 2a will be obviously double of a, but the arrowhead will be in the same direction because the direction of a and 2a will be same, because multiplying with a scalar quantity with a vector and do not change the magnitude of this. Okay, this is how we can represent various kinds of vector with respect to this xy plane or in geometrical. Okay, now let us talk about a more important thing, that is the angle between two vectors. Okay, this is a very important concept that we need here and there, that is the angle between two vectors. So what is the angle between two vectors? First you have to remember the rules, how you should find out the angle between two vectors. First, at any point where you want to find out the angle between two vectors, you have to ensure that the vectors are outwards from this point. So the first thing that you have to check that the vectors should be outwards with respect to the point where you want to find out the angle. Where we want to find out. And the second thing, that the smallest angle, maybe there is more than one possible angle, but you have to choose the smallest angle. So the smallest angle you have to choose. Okay, let me give you an example that you can understand easily. Suppose we have two vectors. Suppose this is a vector A, okay, and this is a vector B, suppose, and this angle is 60 degrees. This is vector B. Now if I ask you what is the angle between A and B, you will reply that it is 60 degrees. But please see, there is another angle also, this is 300 degrees. But which angle you should take? This 60 degrees, because you have to find out the smallest angle. And the first criteria is automatically ensured that the A and B are outwards from this point, you can see. So this is the first criteria you have to satisfy, that the two vectors should be outwards from this point. And then if there is more than one angle, then you have to choose the smallest possible angle, that is here 60 degrees. But if we draw these two vectors in different way, something like this, suppose this is our A vector, and suppose this is our B vector. Now if this angle is given as 60 degrees, then this is not the angle between A and B. Why? Because with respect to this point, you can see A vector is outwards but B vector is inwards. So you have to ensure first that two vectors should be outwards from this point. So how we can do this? We can shift this vector A parallelly from this location to this location. This is a shifting property of any vector, that if you shift a vector parallelly, then the direction of that vector will not be changed. So if the vector is parallelly shifted to this point, this position actually, then we can see from this point these two vectors are now outwards, and we have to take this angle because this is the smallest possible angle, and this angle is the 120 degrees, you can see. So here the angle between two vectors, that is theta, is equal to 120 degrees. Please keep in mind, this is how you can find out the angle between two vectors. Another more possibility I can tell you here also, that if this is a vector A and B vector is something like this, okay, and this angle is 120 degrees, then again 120 degrees is not the angle between A and B, because here also B is inwards and A is outwards. So we have to ensure first that B have to be outwards from this point. So we have to parallelly shift the vector from this point to this point. And now if you see that this angle is the smallest possible angle, that is 60 degrees, So here also theta is equal to 60 degree. That is the angle between two vectors. So please keep in mind these 2 points when you want to find out in any case the angle between two vectors. So you have to keep in mind these 2 points. Then your misconceptions will be gone. Okay. So next we will discuss different kinds of vectors. Okay, there are many kinds of vectors, and we will discuss a lot of things here, but it is not possible to discuss every kinds of vectors in a single sheet, you can say. But we will discuss various kinds of vectors in different topics when we will study different branch of physics. Actually, we will see different kinds of vectors also, but as much as possible we will discuss here various kinds of vectors. So let me first tell you about the equal vector. Obviously, you know a vector has both magnitude and direction. So if two vectors have equal magnitude and equal direction, then obviously the two vectors will be equal vector. So if you have both direction and magnitude are equal, so equal vector should have both magnitude and direction. Should be equal. Should be equal. Okay, suppose this is a vector A and this is a vector B. Suppose if this vector is A and this vector is B, then you can see A is equal to simply B, and the angle between A and B will obviously be 0 degree because they are in the same direction, so it will be just 0 degree. Now if you talk about opposite vector or negative vector, then the magnitude is same but direction is opposite. Here what you can write, that same magnitude but different direction. Okay, but different direction. Something like if this is your vector A and this is your vector B, then obviously A is equal to minus B, and that's why sometimes we call it as a negative vector also, or you can say opposite vector. But the magnitude of A and the magnitude of B is same. So if you talk about a mod A, then obviously that is equal to mod B, and that is here also. If you talk about a mod A, write it equal to mod B. So these are equal vector, these are negative or opposite vector, you can see. Now let us talk about the parallel vector. Parallel vector means the angle between them is always 0. Here you can see the angle is 180 degree. If you talk about angle between A and B, then you can write in this way that this is your A vector and this is your B vector, you can see. So these are outwards from this point. Now the smallest possible angle is 180 degree. Okay. Similarly, if you talk about parallel vector, then the magnitude may not be equal. If the magnitude is equal, then it is also very good. But if it is not equal, then there is no problem. But the directions should be equal. Should have to be equal. Suppose this is your vector A, suppose, and this is your vector B. You can see so A and B vector are not equal in magnitude, but same in direction. Okay, so the direction is same. So in that case, you can write A vector is parallel to B vector. So here you can say that the magnitude may or may not be equal. If the magnitude is equal, then there is no problem. If A and B are same in magnitude, no problem. Here also you can write A is parallel to B, and whenever A is parallel to B, theta will obviously be 0 degree. So equal vector are actually parallel vector also. So these equal vectors you can write they are parallel also. Parallel. Okay, but parallel vector will not necessary that they will be equal. They will be equal. Okay, so what you can write here, that magnitude may or may not be equal. Magnitude may or may not be equal, but direction will be same. But direction will be same. Okay, so this is your parallel vector. Now let us talk about the coplanar vector. Coplanar means the vector will be in the same plane. So there may be different direction, different magnitude, but they are in the same plane. So coplanar vectors are lie on same plane. So they lie on same plane. Very simple. Suppose we have xy plane, something like this. These are x axis and these are y axis, and some vector, something like a vector is in this direction. Suppose b vector is in this direction. Suppose c vector is in this direction. So there is no problem. Any direction they may be, but they are in same plane. Okay, but they may not be in two different planes. Okay, so coplanar vector are in same plane. So this is very simple. Now collinear vector, that means they will be on the same line. So lie on same line. So obviously angle between them will also be 0 degree, you can say. So if you have, this is your vector A, suppose, and along this line if you have another vector, suppose B. Okay, so these two vectors are collinear. And obviously here also you can say theta is equal to 0 degree. But if you talk about coinitial vector, then coinitial vector have same initial point. Okay, if 2 or 3 vector are coinitial vector, then they have same initial point. That's why it is called the coinitial vector. Suppose this is the initial point, this is vector A, suppose this is vector B, vector C, A, B, C. Okay, so they have same initial point. They have coinitial vector. Okay, now coterminal vector, they have same end point actually. They have same terminal point. Same terminal point, that means end point. Terminal. Okay. Okay. So this is your terminal. So in this case, A, B, C, they are co-terminal vector. Now position vector. Position vector is one most important vector. We will discuss more detail later on, but let us tell you just definition of this position vector. Position vector is a vector that actually used to denote the position of any point. Okay, this vector is actually represent position of a point. Suppose we have, let me take again this xy plane. It may be xyz also 3 dimension plane, and here is a point, suppose P, and the coordinate of this point is x comma y, suppose. Now to locate this point with respect to origin, we need a vector from origin to that point, and that will towards this point P, and this vector is known as position vector, is known as small r. Okay, so position vector is just a vector that will use to denote a point with respect to the origin. Okay, and we will discuss a lot of things about position vector later on. So now it is sufficient to know this. Okay, now fixed and free vector. Fixed vector means initial point is fixed here. For fixed vector, initial point is fixed. Initial point is fixed. And for free vector, you know, the initial point is not free. Initial point is not fixed. And initial point is free. Example is position vector that I have discussed earlier. Position vector is position vector, because you know, for position vector you have to mention the initial point with respect to which we want to find the position of P. So this is necessary to specify the initial position. But if you talk about the velocity vector or acceleration, etc., then you don't need to talk about the initial position. So velocity or acceleration, if you talk, then you don't need to mention the initial position. Suppose you said that the car is moving with 30 km/h, so you don't need to tell that with respect to which point. So here initial point is not fixed, that's why they are called free vector, and popular example are velocity and acceleration. So velocity you can say, and acceleration also, right? Acceleration. Okay. Now next, one more important vector, that is unit vector. So unit vector is a vector that is actually used to split a vector with magnitude and direction. So unit vector is a vector that is used actually to give the direction of any physical quantity or any vector quantity actually, but its magnitude will be 1, obviously. So in simple notation you can tell that the unit vector is a vector whose magnitude is 1, but useful vector, it is very useful vector. So unit vector is a vector, the magnitude of, you can write the magnitude of unit vector is 1, but we will use this vector actually basically to write the direction of any vector. Something like we have a vector A, suppose, and the modulus of this vector is just A, and suppose the vector is something like this. Now how you can represent this vector A, or how you can split the vector A to write the magnitude and direction separately. So this, when you denote something like this is denoted with both magnitude and direction. This is a vector quantity complete. It means that it have direction and it have magnitude also. But can you write this A vector with magnitude and direction? So if the magnitude of A is A, simply you can write A, and if you denote the direction here, then it will completely denote the vector A. So you can write a direction, you have to write a direction here, and direction means obviously it's a vector quantity, so you have to write a vector here, but you have to use that kinds of vector which do not change the value of A. So unit vector is the only possible vector here we can use. So if you use here a vector, the direction of which is along A and the magnitude is 1, then it will correctly give the direction of A, and obviously the magnitude of A will not be changed because it will multiply by 1. So if you use a unit vector something like A cap, and the A cap have the direction along A, so if you write a vector A with its magnitude and direction, then you have to use this unit vector. You cannot use any vector other than unit vector to write a vector with magnitude and direction. So this is why the unit vector is more useful. So sometimes we have a magnitude of a vector, and if we multiply with a unit vector, then we will get the complete vector. Sometimes it is popularly written in this way also. Just A cap is actually A vector divided by mod A. So if you divide the vector with its magnitude, then obviously you will be left with the direction only. So sometimes this is also the popular notation of any unit vector, that if you divide any vector by its magnitude, then you will get the unit vector. But you can understand in this way also, that if you want to write a vector with its magnitude and direction both, then you can write in this way. Okay, and there are 3 popularly known unit vector along x, y and z axis. So if you have any physical quantity along x-axis, and if vector quantity along x-axis, and maybe it is along y-axis, and maybe it is along z-axis. But if you want to write a vector quantity, if you want to give the direction of a vector quantity along x-axis, then you have to multiply with I cap. So I cap is the popularly known unit vector along x-axis. Similarly, j cap is the popularly known unit vector along y-axis, and k cap is popularly known as the unit vector known along z-axis. So these I, j, k are sometimes called triads, but this is very important. Okay, sometimes the notation may be changed. Suppose in this direction, some people can write x cap along this direction. Instead of j cap, we can write e cap. Instead of k cap, we can write z cap also. But they have same meaning. Sometimes in most standard textbook, you can see something like this: ex cap, ey cap, and ez cap also. But they have same meaning. So we can write unit vectors along x, y, and z axis. These three popularly ways, something like I cap, j cap, k cap. You can write in this way along x, y, z axis. Or if you want, you can write x cap, y cap, z cap, and ex cap, ey cap, ez cap. Okay, but they have same meaning. Okay, so this is a very important vector that will play an important role in total vector algebra, and not only vector algebra, in various branches of physics. Okay, now let us talk about the zero vector. What is zero vector? Zero vector is a vector whose magnitude is zero. Magnitude zero. Yes. Magnitude zero. And this is a vector whose initial point and final point is same. So it is just a point. The length is zero. The length of in geometrical plane, to denote a vector by a straight line with an arrow. But if it is magnitude zero, then obviously the length of this line is zero. So it is just a point. So its initial and final point is same. So for zero vector, initial and final point is same. Final point is same. And there are some important property of zero vector. If you have two same vectors, something like A, and if you subtract these two vectors, then you will get zero vector. So we will study this subtraction later on. Similarly, if you add a vector with zero, you will get that vector always. Or something like if you multiply the vector, you will get zero also. This is zero vector obviously. So we will discuss later on the various kinds of addition property. Okay, but for zero vector, you should remember this. And that is a physical situation I can give you for this. Something like if you have an object of mass m, and if you give a force along this direction and another force along this direction. Okay, the net force, if you say net force on this block is zero, because F and F is same here. This is just nothing but, you will see later on, this is just a minus. This is the subtraction of two vectors that will give you the zero vector. Okay, so we will discuss later on when we talk about the vector addition and vector subtraction. But at this point, it is sufficient to note that zero vector has the magnitude zero and its initial and final point is same. Okay, now let us talk about the pseudo vector and the true vector. So pseudo vector means actually this is axial vector, or you can say the rotational vector, axial vectors actually, and the vectors involving with rotation. Vectors involving with rotation, or involved with rotation. Something like angular displacement, or angular velocity, this kinds of things. So we will discuss these kinds of vectors, rotational motion or circular motion. But true vector, or sometimes these vectors are called polar vector also, and these are actually the vector that we will use in kinematics. Something like simple displacement, acceleration, this kinds of thing, force. So simple displacement means translated for translator motion, the displacement, and you can say that the acceleration. So these are just true vectors. Okay, so and why these are called pseudo vector we will discuss later on in the chapter circular motion. Okay, so these are different kinds of vector that I have discussed, but there are a lot of vectors also that we will get in different branch of physics, and there I will discuss that kinds of vector also. Okay, but now at this point it is sufficient to know these kinds of vectors also. Okay, so please revise the whole things, and we will discuss from the next class. We will discuss basically the vector addition, vector subtraction, main vector algebra will start. Okay, so for today this is enough, and if you are new in this channel then please subscribe this channel. We will continue our lectures in details, more details, and we will reach up to JEE advanced level. Okay, thank you.